Hello kiddos, how are you? Welcome to the PW Gulf. This is the summary session of the chapter Application of Derivatives. A very important chapter. Why do I say it's very important? Because it holds a marks of weightage of 10 marks in the board examination and around 3 to 4 questions in the JEE examination, JEE mains paper as per the previous year paper analysis. So that means yes, around 12 to 15 marks in JEE and 10 marks in boards, which is a big number, isn't it? Yes, that is what makes this chapter a important one. Hope so that before studying application of derivative, you have studied derivative, you know what is continuity, differentiability, and those simple things, how to differentiate any function. These are all the different applications on this chapter list. The first application, rate of change, increasing, decreasing function, tangent and normal, approximation and maxima minima. I am not cutting down or deleting any of the thing which is not there in your CBSE. Here you will get everything, you know that, because our target is competitive examinations also. Alright, get set to study this 5 applications with absolute details, everything, notes provided to you on screen by myself. Okay, go for it. So first quantity, rate of change. Very first application of derivative is rate of change. Rate of change? Yes. When you differentiate any function, let's say x is your position. X is position with respect to time. When you differentiate, you get velocity. Similarly, if you differentiate your velocity with respect to time, you get acceleration. And when you differentiate acceleration with respect to time, what do you get? You get, yes, absolutely, whatever you are, that's what you get. It's called jerk, right? So this is a very simple application of derivative, isn't it? The first and the simplest application of derivative according to physics. Next application will be according to mathematics. This is the physical meaning of slope. This is the physical meaning of derivative, rate of change of one quantity with respect to other. So rate of change of y with respect to x is dy by dx. If you're calculating at a given point, then dy by dx at x equal to 0. This is how it's written. Dy by dx, if the rate is positive, that means y is increasing, x is also increasing. If dy by dx is negative, when x is increasing, y is decreasing. When x is increasing, y is decreasing. Negative acceleration, you all know. With time, acceleration decreases. And dy by dx is 0, that means there is no change in y with respect to x. When x is changing, y is not changing. A constant dead function. No change. Okay, now in the question what we need to remember is what have they asked. If they have asked rate of change, find rate of change, then you will answer in terms of sign, whether the rate is positive plus 5 or minus 5. The rate of change is plus 5 or the rate of change is minus 5. You will mention the plus and minus. But if the question says find the rate of decrease, question itself says find the rate of decrease. So will you say the rate of decrease is minus 5? The rate of decrease is minus 5. Doesn't make sense, right? We will not say minus 5. We will say the rate of decrease is 5. And whatever is the unit after that. Rate of decrease of what? Area with respect to time, or volume with respect to time, etc. So if rate of decrease is mentioned already, no need of showing the sign, magnitude is enough. If only rate of change, you have to show the sign. Okay. So let's see. The line going down, slope negative. Line parallel to x-axis, if this you imagine as your x-axis, parallel to x-axis, slope is 0. Going up, dy by dx is positive. You can also understand with respect to why is dy by dx negative when x is increasing, y is decreasing. Why it's 0 when x is increasing, y is remaining constant. Here is your y. This is y-axis, suppose. Why here it is positive? Because when x is increasing, as you're moving towards the right, y is also going up. X increasing, y increasing, x, y both increasing, dy by dx positive. This will help a lot in the next application, which is increasing decreasing functions. This is exactly what you will do in increasing decreasing function. Now once again, can you see, if you think of this as an x-axis and this as your y-axis, x is increasing, you're moving on the right. When you move on the right on x-axis, 1 2 3 4, x value increases, x increasing, y is also increasing, positive dy by dx. Your x increasing, y remains constant at this point, derivative is 0. Here, when you increase the x, as you're moving on the right side, the curve is going down. The value of y is coming down. Dy by dx is negative. Simple to understand? Great. That's all is the theory for rate of change. That is all you need to know for theoretical part. Let's do a question and then go to the next application. I've taken like 1, 2, 2 questions in each of the application just to give you a gist of what you are supposed to do in such questions. Well, varieties, there are a lot of varieties. As I promised, we will do that in the detailed lectures. A balloon which always remains spherical is being inflated by pumping in some amount of gas. 900 cubic centimeters of gas per second. Find the rate at which radius of the balloon is increasing when radius is 15 centimeters. Find the rate at which radius is increasing. So always in a word problem, read the question, try to write down what is given, what you have to find, and then proceed with whatever is given to you. Start with that. In this question, what is given? They are pumping in 900 cubic centimeters of gas per second. So isn't it volume? If you get ever confused, look at the unit. Centimeter cube, that means it has to be volume. If it was centimeter square, then it would be area, surface area. So this unit helps us a lot in understanding what is given whenever there is a confusion. So cubic centimeter, rate of change of volume per second, that is with respect to time. dV by dt is 900 cubic centimeter per second. Why positive? Because air is added in the balloon. The rate of change increases, the balloon will increase. The air is not removed. If it was removed, negative. If it's added, positive. Simple logic. That's given. What is to be found? We need to find rate of change of radius with respect to time when radius is 15 centimeter. Guys, remember whatever information is given here, this substitution should be done only in the last step. Don't mess it in between, only in the last step. Solution. Now, obviously we don't know where to start from. Start with the volume directly. Volume of a sphere is given by a formula 4/3 pi r cube. You are all very lucky that there is only one variable here. There is only r. So differentiation is very easy. You differentiate with respect to time, you'll be able to get the answer. We know dv by dt, we know dr by dt is to be found. But if there were two variables like r and h both, in such a case, you have to convert the two variables in one variable. That is, this h should be turned into r or r should be turned into h. How? For that, some extra information will be given in the question. For now, it's not there, but you will come across such a scenario in the last question of this session, which is maxima minima word problems. And with that, you can connect. Whatever we are doing in that last problem, same thing you have to do in such questions. Converting two variables to one variable is a very important part. Well, as I said, it's very easy now. Go for differentiation with respect to time. dv by dt is 4 pi by 3 constant. Derivative of r cube will be 3r square into dr by dt. 3 cancels. Therefore, dr by dt is equal to, what is dv by dt? 900 upon 4 pi r square. Dr by dt, in the end I'll put r is equal to 15. That gives me 900 upon 4 pi, r is 15 into 15. How much we get? 15 ones are 15 60s are 15 ones are and 15 fours are. 4 and 4 cancel. 1 upon pi. 1 upon pi. What should be the unit? Radius is centimeter. Time is second. That's the answer. Do not forget, final answer should be in terms of statement, because it's a word problem. Statement has to be there. Find the rate at which radius of balloon is increasing. Answer. Radius of balloon is, they have already mentioned increasing. So increasing at 1 upon pi centimeter per second. Done. The question is sorted. Nice. You got 2 marks. Congratulations. Next application, the second application is tangent and normal, which is increasing, decreasing. Increasing, decreasing. Tangent, normal is the third application. Increasing, decreasing I have kept at second number according to your textbook. Although I feel tangent, normal should be second, ordering wise. No ways, no problems. Yes, derivative can also be used to find whether a function is increasing or a function is decreasing. Increasing, going up, decreasing, going down. Constant means no increasing, decreasing, nothing happening to it, just a constant. So easy. That means if your first derivative is greater than 0, you will declare it positive. Less than 0, equal to 0. So simple, fundamental, right? For solving question, that's all you need to know. But my aim is to tell you a little extra. I mean, why to stick just step to step? A little extra information is not harmful, isn't it? So if you're interested, strictly increasing when I say. Strictly increasing. Notice this 2 points, x1 and x2. On the x-axis, I have taken 2 points, x1 and x2. Do you all agree that x1 is less than x2? As you move on the x-axis, the right-hand quantity is always greater, left-hand quantity is always smaller. Like 1, 2. 1 is smaller, 2 is bigger. Like that. Okay, when you notice the corresponding functions, so here it is f of x1, f of x2. Which one is bigger? On y-axis, as you go upwards, value increases. 1, 2, 3, 4. So the one which is below is less. F of x1 is smaller than f of, correct? x1 is less than x2, f of x1 is less than x2. That's exactly means your function is going up. This is the condition for a function to be increasing. Or I should say strictly increasing. I should say strictly increasing. If this was equal to, then we will say only word increasing. But if it is not equal to, f of x1 is strictly less than f of x2, nowhere they are coming equal, then it is an increasing function. Let me take an example like this. Yeah. Can you see? Here, this is an increasing function. It is going up. But at some point, it is also equal. At this portion, in this area, the f of x1 and f of x2 are equal. It's constant. Like it's going up, then constant, then going up. So overall, it's increasing, but not strictly increasing. Here, x1 is less than x2 and f of x1 can be less than or equal to f of x2. It is called, this is strictly increasing and this is just increasing. Alright. Similarly, if you go for decreasing and strictly decreasing, notice here, x1 is less than x2. But f of x1 is greater than f of x2. It is not the thing you were thinking of. x1 is less than x2, but f of x1 this time is greater than f of x. Such a function is called as strictly decreasing. Strictly decreasing. You can see from the graph also. But what if in the question graph is not given? Then this information is helpful. You check their x, then you check their corresponding values. Same, increasing. Different, they both are different signs, decreasing. Next. x1 is less than x2, but f of x1 is equal to f of x. Your x is changing, but f of x is not changing. then it's neither increasing nor decreasing, or you can also say constant function. So whatever I just said has been written here. Increasing means x1 less than x2, f of x1 less than equal to f of x2. Strictly increasing means you can see there is no equal to here. Decreasing means opposite sign, less than, greater than, less than, greater than. Constant means this is equal to. The functions are equal no matter what. Understood? This is definition of increasing and decreasing function according to the textbook, and it is also good to know because you might have questions on assertion, reason, case study questions where such information is needed. It's not just related to solving questions. We need to know the background for getting good scores, isn't it? When I say a function is neither increasing nor decreasing, now notice this. From x1 to x3, in the interval x1 to x3, the function is at some point increasing, at some point constant, at some point decreasing, then constant, then increasing. That means overall in x1 to x3, what do you say? You will say it is neither increasing nor decreasing. You will simply declare. If I ask you, what is the function in x1 to x3, increasing or decreasing? You don't have any third choice. Like you cannot say, ma'am, x1 to x2, it is doing this. Like, okay, ma'am, x1 to c, it is increasing, then c to x2 decreasing, then x2 to d decreasing, then d to x3 increasing. I'm not asking you the breaking up. I'm asking you x1 to x3. What is happening? You will say, ma'am, it's neither increasing nor decreasing. Are you clear? And there is a word monotonicity which we'll also encounter while solving questions. Monotonicity is when the function is either increasing or decreasing. You will say it is a monotonic function. Like there is no ups and downs. If there are ups and downs, it's non-monotonic function. Non-monotonic. Increasing. So boring. Monotonic life. Decreasing. Boring life. Decreasing, monotonic. So while solving questions, this is what matters to us. First derivative greater than, less than and equal to 0 will tell us whether function increases or decreases. Steps written here. Guys, this 5 steps. Now this chapter you will do with me with the help of steps. I know it gets confusing at times for the students, and that's why for all the applications, I have written down these steps. For rate of change I have not, but for increasing, decreasing, tangent, normal, maxima, minima, everything, errors, approximation steps are given to you. Write down the steps in your book and try to solve questions using them. You will be able to do it. All my experience has been put in this. And then here, the first 4 steps, whatever first 4 steps you are learning, same first 4 steps you will do in maxima, minima also, local maxima, minima. So the first 4 steps, if you practice very well in increasing, decreasing functions, you don't have to worry. Same thing you have to do in maxima. Put 100% efforts here, so that 10% of efforts in maxima, minima, if you put, you're done. F of x, f dash of x. Find f of x, find its derivative, put the derivative equal to 0 in order to get critical point. I hope you all know wavy curve. Wavy curve method is something which we study in class 11th also in the chapter linear inequality. If you have not studied, you can still go back to basic mathematics lecture which I have put on the YouTube channel and study wavy curve method. I always recommend students before studying the chapter application of derivative, it is a must for you to know wavy curve. If you don't know, please don't go ahead. Stop here, learn wavy curve, then come back. Wavy curve method in basic mathematics, it is there. Wavy curve method, well, even though it's not allowed in CBSE, there is another method called the table method. You must have studied it in your school. You prepare a table and try to find the sign of f dash of x. All that matters to us is sign of f dash of x, positive, negative or equal to 0. So 2 methods to find sign of f dash of x, table method and wavy curve. I prefer wavy curve because I know you all have learned table method in school. Wavy curve is for objective questions. If the question is objective, multiple choice question, who cares about the step? You just need the answer. So wavy curve will be very helpful. But wavy curve is not helpful in all the questions. Only the questions in which you can apply wavy curve, like the algebraic ones. है ना? If the question is trigonometric, then of course you cannot use wavy curve, you have to go for the table method. So both the methods are important. Looking at the question, I'll do both the methods, don't worry. So once you find the sign of f dash of x on the number line in different regions, based on this you will conclude whether it's increasing, decreasing or constant. Write down these 5 steps and we are good to go for the question. Let's get ready. What say my बच्चा लोग? मेरे प्यारे बच्चों, क्या हम इसको solve करें? हाँ, करेंगे. Find the intervals in which this function is increasing or decreasing. Question is find the intervals. Solution. What was the first step? Write the function. What was the second step? Find its derivative. Derivative of x by 2 is 1 by 2. Derivative of 2 by x is minus 2 by x square. Can we simplify it something? Yes. It is x square minus 2 2s are 4 upon 2x square. I can also rewrite f dash of x square minus 4 as x minus 2, x plus 2 upon 2 times x square can also be written as x minus 0 the whole square. Just factorizing terms, nothing else. Alright. What was the third step? Once you get f dash of x, put f dash of x equal to 0 and get the critical point. If first term is put equal to 0, x will be 2. If you put second term equal to 0, x will be minus 2. And there is one more term in the denominator, x minus 0 equal to 0, you will get x as. These are the 3 critical points. Third step done. Third step done, isn't it? Fourth step was decide the sign of f dash of x. Which method shall I use? In this particular question, we can use wavy curve. So I'll just show with the wavy curve. On a number line, what you do is, on a number line, you will plot all the critical. The critical points are minus 2, 0 and in the order. Well, x is overall positive, so start with a plus sign. This 2. 2 comes from a term which has odd power, so plus change to minus. 0. 0 comes from a term which has even power. Even power means minus will continue to be minus. Minus 2 comes from a term which has again odd power. So minus changes to plus. This is your sign, and this sign clearly tells us where the function is increasing and where it is decreasing. Fifth step. Where it is increasing, can you see the plus signs? Minus infinity to minus 2, union 2 to infinity. This is where your function increases and the function is decreasing in minus 2 to plus 2. Correct? Negative, negative. Well, if you don't like the tabular method, wavy curve method, draw a table. The table will have some interval and nature. 3 columns. Very good. The first one is interval. I'm just doing the fourth step again. Sign of f dash of nature of f of x. Interval. Which are the intervals that you get? Number line you have to anyways draw. What are the intervals which you get? Minus infinity to minus 2, then minus 2 to 0, 0 to plus 2 and 2 to infinity. These are the 4 intervals we get on a number line. We have to analyze these 4 intervals. In minus infinity to minus 2, you take any point in this interval. Let's take any number less than minus 2, minus 3. Take minus 3 and put it in this. Put it in f dash of x. Either you can substitute here or here. Up to you, your choice. If you put here minus 3, it will be 9 minus 4, 5 upon positive number. Numerator positive, denominator positive. Overall, you are getting positive. And if f dash of x is positive, overall you are getting f dash of x greater than 0. If f dash of x is greater than 0, can we say that the function is increasing? Okay, if you don't understand where to put, you can put here also. Minus 3, minus 2, minus 5, you will get negative. First bracket, you will get negative. Minus 3 plus 2, second bracket also negative. Denominator, minus 3 minus 0 the whole square, denominator is positive. So what is negative into negative upon positive? Negative, negative, positive, positive, positive. So this is also positive. So both ways, either you substitute here or here, you will get a positive. Minus 2 to 0, and take any point here. Let's take minus 1 and substitute here. Minus 1 minus 2, minus 3, negative. Substitute here. Minus 1 plus 2, positive. And denominator is always going to be positive. Do you agree? Denominator is square. So you can also ignore the denominator. Negative, positive, positive. It's overall negative. That is, your f dash of x is less than 0, function is decreasing. Correct? You got decreasing. Wavy curve like solves it like this. 0 to 2. 0 to 2. Take any point. 1. Put 1 minus 2 negative. 1 plus 2 positive. And the denominator is always positive. Negative into positive, negative. Your f dash of x is less than 0, function is decreasing. Wallah. And last, 2 to infinity, take any point. 3. 3 minus 2, positive. 3 plus 2, 5, positive. Denominator is always positive. Your f dash of x is greater than 0, function is increasing. That's how you will show in your CBSE. The fourth step, this is how you will show. And then fifth step, conclude, you will get your full marks. You will get 4 marks. Telling you, it's a 4-mark question. 5 steps, 4 marks. Awesome. One more question. Determine the interval in which this is increasing or decreasing. You must be waiting, ma'am. Trigonometry le lo na yaar. I told you, na 4 steps are same in increasing, decreasing and maxima, minima. So I have taken trigonometry in maximum. You will understand. Just 4 steps same, 5th step changes and you get maxima, minima. For curiosity, because I just can't hold it inside. Maxima, minima is going from positive to negative. Minus 2 will be maxima. Negative to negative. Oh, it's point of inflection. Negative to positive. This point is 2 is what? Minima. So maxima, point of inflection and minima. That's your maxima, minima. Done, boss. Nothing else. You don't have to do all this. Khatak. Remove. All this is not needed. Only 4th step and you get your maxima, minima. निकाल देते है ना. चलते हैं बेटा. Determine the interval in which this function increasing, decreasing. अरे यार, I am not going to solve it पूरा. First step, write the function. 5 steps. 5 steps. You all start doing along with me. What are you waiting for? Second step, f dash of x. 4x cube, 3 8s are 24x square, plus 22 2s are 44x minus 24. Can something be taken common? 4 can be taken common. X cube minus 4 6s plus 11s. Alright, it's a cubic equation. What to do now? Well, in basic mathematics, we have learned the hit and trial method to factorize such a cubic equation. Do you remember? How to do hit and trial? We write down all the coefficients. 1, minus 6, 11 and minus. And then we try to put any number here. We try to hit with any number. Mostly 1, minus 1, 0, 2, minus 2, half and minus half. These are the numbers we try. Let's try with the basic 1 number. Bring this vertically add, diagonally multiply. Vertically add, diagonally multiply. So 1 comes down. 1 into 1, 1. Minus 6 plus 1, minus 1 into minus 5. 11 minus 5, 1 into 6, minus 6 plus 6, 0. If you get 0, voila, that's correct. It's a correct hit. Done. Very good. This will be written as x minus 1, and these three terms will again form a quadratic x square minus 5x. How do you factorize this? Isn't it x minus 2 into x minus 3? Well, the quadratic equation has been factorized as x minus 1, x minus 2, x minus 3. F dash of x dash. Second step. Third step, putting the first derivative equal to 0 and getting the critical point. Implies x is equal to first term, if you put it equal to 0, you'll get 1. Second term 2, third term 3. These are the three critical points. Now, on a numbered line, plot this. Minus infinity to plus infinity, 1, 2, 3. 1, 2, 3. What are the regions? 1 region, 2 region, 3 region, 4 region. So, if you are making a table, you will again make 4 regions, and in each region pick up a point, substitute and check whether it's positive or negative. Interval line of f dash of nature. Minus infinity to 1, 1 to 2, 2 to, this is 3, right? 2 to 3 and 3 to. If you all know wavy curve, these are all odd functions. X is overall positive, so plus, minus, we have got the answer. The function is increasing in the interval 1 to 2, union 3 to infinity. The answer is already obtained, and decreasing in the interval minus infinity to 1, union 2 to. But with this technique, let's try to find out. Take any point between minus infinity and 1. Any number less than 1? Oh, 0 is the best, isn't it? Put x as 0. First term, negative. Second term, negative. Third term, negative. Negative, negative, positive, negative, less than 0. Less than 0 means decrease. Take any number between 1 and 2. 1.5. Substitute here. 1.5 minus 1, positive. 1.5 minus 2, negative. And 1.5 minus 3, negative. Positive into negative, overall positive, increasing. 2 to 3, any point, 2.5. Substitute. 2.5 minus 1, positive. 2.5 minus 2, positive. Right. 2.5 minus 3, negative, plus, plus, plus into minus, less than 0, decreasing. And any number greater than 3, 4. 4 minus 1, positive. 4 minus 2, positive. 4 minus 3, positive. All positive, increasing. Exactly, you get the answer. We are doing questions by both the methods. Hope you will be able to get all the fruits from this. Next topic, the third application is change in normal. The geometrical significance of derivative. You all ask a question, ma'am, why are we studying derivative? It has two significance. Physical is rate of change, like velocity, acceleration, jerk. And geometrical is slope of tangent. Derivative is nothing but when you find the derivative of any function at a point, you are trying to find the slope of this tangent. At any point of the curve, if you draw a tangent, what is the slope of tangent? It's dy by dx. So function will be given in the question. You differentiate it. That will give you slope of that tangent written as mt. And slope of normal. Normal is a line perpendicular to the tangent, passing through the point of contact. Point of contact generally we take x1, y1, point P. Any line passing through this point and perpendicular to tangent is called as normal. Slope of normal is mn, which is negative reciprocal of slope of tangent. Slope of perpendicular lines is -1, and if you want to find mn, -1 by mt. Negative reciprocal. Negative reciprocal. Okay. So while solving the questions are generally find the equation of tangent and normal. In order to find equation, we need two important things, and that is slope and point. Once we know slope and point, you can very easily find the equation. Do you agree with me? Slope is differentiating the curve. Once you differentiate the curve, you'll get a slope. Slope, very easy to find. Differentiate the curve, get the slope. And once you know the slope, find out the equation. Y minus y1 is m into x minus x1. If it's normal, just mt changes to mn. Point is same x1, y1. Y minus y1 is equal to m into x minus x1. So slope and point are two important things. Based on this, the three different types of questions can arise. And now whatever I'm going to show you in the next slide is going to be super important for all of you. If you do not take it seriously, it's your loss. And if you write down what is there on the next slide, your life will be sorted in each and every question of tangent and normal. That's my promise. There are three types of questions. First, find the equation of tangent and normal at a given point. Given point means point is given to you. You need two things. My boss, my bacha log, you need two things. Slope, point. In first type, point is given to you. Very happy. Find the slope, get the answer. Find the slope, question solved. In second type, equation of tangent and normal having given slope. In second type, slope is given to you. Find the point, question solved. And in third type, you must have guessed, equation of tangent and normal passing through a given point. No, it's not. No, point is not given. It's misleading. The tangent is passing through that point. The tangent is passing through that point. This point is nothing but x2, y2. We don't know x1, y1. We don't know the point at which you are calculating the slope. We don't know the point at which you are calculating the slope. So neither the point is given nor the slope is given. Neither the point nor the slope. Type 3. So neither the point nor the slope. So then what is given? Some extra information. Where is your tangent passing through or where is your normal passing through? Whatever I have written for tangent, same is for normal. Once you know tangent, you all know, you can easily find normal. Okay. So steps to solve such type of questions also is written in front of you. First type, where the point is given to you. There is a curve. You want to find it. Point is given, x1, y1 is given. Just differentiate the curve. Y equal to f of x and x1, y1 given. Differentiate it to find slope of tangent. If you need normal, use the formula. And use the equation y minus y1 equal to m into x minus x1. You will get the equation. First is very easy. Okay, second type. In second type, yellow color. You're trying to find point is not given. Slope is given. Now I've written empty. Similarly can be done for normal. Slope of normal is given but point is not. So y equal to f of x and mt or mn is given to you. You will differentiate the curve. And because the slope is given, point is not given. Find out the point. Differentiate it dy by dx and equate it to the point. So when dy by dx is equated to x1, y1, you will get one equation in x1, y1. You need two things. x1, y1, two unknown. So you need two equations to solve it. Two unknowns, two equations. How to get two equations? First, differentiate, equate it to the slope given, and you will get one equation. Second, substitute x1, y1. This x1, y1 you will substitute in the equation of curve. You will substitute in y equal to fx. x1, y1 lies on the curve. Substitute, you will get second equation in x1, y1. These two equations should be solved simultaneously. When you solve these two equations, you will get x1, y1. And once you know the slope already given, point you have found, equation can be easily found out. Are you able to understand? I know it's all in the air, but if you have studied this topic already, you will be able to relate, I promise. If you have not studied, just write down and check each question. Question yourself, type 1, type 2, type 3, and follow the steps. We'll get the answer. Type 3, when you neither know the point nor the slope. In such a question, y equal to f of x is given and x2, y2 is given. This point, x1, y1 is not. You will differentiate y equal to f of x to get the slope. Also, mind it, these 2 points, y2 minus y1 upon x2 minus x1 will give us the slope using 2 points. So yeah, this is one slope. The other slope is obtained by differentiating. Equate them and you will get one equation in x1. Equating these two, you will get an equation in one equation. How will you get the second equation? The usual way. Put x1, y1 in the equation of curve. Substitute x1, y1 in the equation of curve. You will get second equation. 1 and 2, solve and get x1, y1. Once you get x1, y1, and you can also substitute that x1, y1 in equation 1 to get slope. You have slope, you have the point. Find out the equation. Y minus y1 is m into x minus x1. Slope and point is the target. This is the slide. Here, subsolve 1 and 2, find x1, y1, and I will add a step. Here I will add a step. Substitute x1, y1 in equation 1 and find m. Find slope. So you know slope, you know point, you can get the equation. Done. So the magic is over. One more thing in tangent normal is finding the angle of intersection. Now finding the angle of intersection between two curves. When I talk about angle of intersection between two curves, I am actually talking about angle between their tangents. I am actually talking about angle between their tangents. Formula is tan theta is m1 minus m2 upon 1 plus m1 m2 in the mod. m1 m2 are the slope of two tangents of two curves. When they say that the curves cut orthogonally, when the curves cut orthogonally, that means that tangents are perpendicular. The tangents are perpendicular. Curves cut orthogonally. When tangents are perpendicular, this slope, product of slope is minus 1, theta is 90. And when slopes are equal, theta is 0. They will not cut. They are parallel. So theta is 0. Right? Let's do couple of questions on them. There we go. At what point of the curve y equal to x square does the tangent make an angle of 45 degree with the x-axis? Now you all know the formula of slope. Slope is tan theta. Slope is y2 minus y1 upon x2 minus x1. Here, have they given the slope to us? Very well, they have given us. Slope is equal to tan of theta, where theta is the inclination. Theta is given to be 45 degree. Tan 45, 1. Slope is equal to 1. Slope of what? Tangent. Wow. They have asked you the point. Which type it is? Type 1 or type 2 or type 3? It is type 1. Slope is given, no, type 2. Slope is given, find the point. Is it type 2? Slope given, find the point. Slope given, find the point. Type 2, find the point. And what do we do in type 2? Whatever it's written there, no, you will do the same. First, y equal to x square. Differentiate it. dy by dx is equal to 2x. dy by dx is nothing but slope of tangent is equal to 2x. Slope of tangent is equal to 1, and you can also say dy by dx at point x1 is equal to 2x1. This is slope of. What is the value of slope of tangent? 1. Therefore, 2x1 is equal to 1. It means x1 is equal to 1 by. we are nearing, we are finding x1, y1 very soon. How to find y1? Substitute x1, y1 in y equal to x square. Why? The x1, y1 will satisfy equation of curve. Therefore, y1 is equal to x1 square. That is, y1 is equal to, substitute x1 as half. Y1 is equal to 1 by. What is the question? Question is find the point. Have you got the point? Therefore, point is x1 comma y1 half comma. If they would have asked find the equation, you know the slope, you know the point, use the equation. Y minus y1 is m into x minus x1. Question is short. Right now they have kept it like for 3 marks. They can make it 4 marks by finding the equation. So are we doing the same steps I've noted there? Yes, ma'am. Absolutely same. Slope is given, function is given. Slope is given, function is given. Differentiate it, equate it to, dy by dx equal to mt, you will get an equation in x1, 1. Equation 1. Then substitute x1, y1 in the curve. You will get equation 2. Here we get equation 1. Substitute x1, y1 in curve. You will get equation 2. Solve this 1 and 2. That is, substitute x1 equal to 1 by 2 in equation 2. You will get your. Once you got that, gist of it has to be understood. Next question, guys. Find the point. Once again, find the point on the curve defined on the interval 2, 3 where the tangent is parallel to chord joining the endpoints of the curve. It's a little twisted question which I've taken very purposely. Just try to figure out. Find the point is the question, type 2 mainly. But your curve, I don't know what the curve is. I've randomly drawn a curve for picturization. Your curve is in the interval 1 to 2. So we are finding curve in the interval 1 to 2, where tangent is parallel to chord joining the endpoints of curve. So if this is chord, if this is the chord, tangent will be parallel to, my tangent is parallel to chord. Can you see? Maybe not fully parallel. Can I draw properly parallel? Yeah, somewhat you must have. And this point is x1, y1 which you have. Looking at this diagram, tangent parallel to chord, what can we find? See, for finding point we need to know the slope. Can we find the slope of tangent? Very easily. What is slope of chord? Slope of chord. When you know 2 points, can we find the slope of chord? Do we know these 2 points? Yes, we know. How? Substitute x as 1 in the curve. X equal to 1 in y equal to root of x minus. What will you get the value? Y is equal to, no, it's 2, 3. Why did I write 1, 2? 2, 3. Sorry. This point is 2, this point. Put x as 2, put x as 3. You will get the y. Substituting x equal to 2 in this, y is 0. It is 2, 0. And substitute x equal to 3 and y is equal to root of x. You will get 1. This 2 and 3 lie on the curve. Putting x2 you will get y, putting x3 you will get y. Slope of chord will be equal to y2 minus y1, 1 minus 0 upon x2 minus x1, 3 minus 2. This is 1. Slope of chord is 1. Do you agree that slope of chord will be equal to slope of tangent? Because they are parallel. And that means mt is equal to 1. Slope of tangent is 1. We got the slope. We need the point. This is type 2. We got the slope. We need the point. In order to find the point, y is equal to root of x minus 2. Differentiate. dy by dx will be derivative of root 1 upon 2 root x minus 2. dy by dx at the point x1, y1. We want slope at given point. 1 upon 2 root x1 minus. This is slope of tangent. But slope of tangent is equal to 1. So use these two equations. Equate 1 upon 2 root of x1 minus 2 is equal to x1. Square on both sides is equal to 1. Therefore, 2 root x1 minus 2 is equal to 1 square. 4 x1 minus 2 is equal to 1. x1 is equal to 1 by 4 plus 2. That gives x1 is equal to 9 by. Very good. Once you get x1, how to get the other coordinate? x1 comma y1 satisfies the equation of curve. Satisfies y is equal to root of x1. Therefore, y1 is equal to root of x1 minus 2. Substitute x1. y1 is equal to 9 by 4 minus 2. 9 minus 8 root of 1 by 4, which is y1 is equal to 1 by 2. x1, y1 known to us. Final answer. Therefore, point P x1, y1 is equal to 1 by 4, 9 by 4, 1 by 2. Question is, please check. Why am I doing questions on finding point and not full equation? Because here on you can take it very well. Slope and point is what you have to chase. And in both the questions, slope and point was not given directly. Here it was not given directly. We had to find, but easy. Here also it was not given directly. We had to substitute, find the slope of chord. That gives us the slope of tangent. But yeah, we are successful in finding slope. And then through the same process of finding point, we can find the point. Repeatedly, if you do questions, you will be able to solve it very well. मच्छर बहुत काट रहा है कब से मुझे. Fourth application, approximation and errors, guys. Tangent, normal, all the very best. Approximation. It is used to find approximate value of functions. Like you all know what is square root of 25. But if I ask you square root of 25.2, थोड़ा सा change हो रहा है. No, slight difference. So for finding approximate value of such functions, we will use the technique. What is the formula and what are the steps? Here it is. How it is derived? It is simply your first principle of derivative. You arrange the terms here and there, putting your remove the limit and arrange. This is what you get. First principle of derivative. F of x plus h is approximately equal to h into f dash of x plus f of x, where h is that small difference, you know. Here it's 25 and here it's 25.2. So whatever you are supposed to find, count it as x plus h. In this, x will be 25, h will be 0.2. Can you see h is that small iteration which is happening? That small difference, very small difference. We know root of 25, we don't know root of 25.2. So 0.2 is extra, that is h. Let's say it is extra. X is something known to us. X is known to us. Now we know our x. Throughout our life, we have been finding x. Algebra is all about finding the value of x. Find x, find x, find x, find x. This is different. Here we know x. Isn't it amazing? Now, we know x, we know h. We need f of x plus h. We need this. So find x plus h, x and h. So x plus h, 25.2, 25.2. Then find f of x and f dash of x. Root x and derivative of root x, 1 upon 2 root. Substitute x in f of x and f dash of x. Substitute 25, that is root 25, 5, and 1 upon 2 root 25 is 1 by 10. And then use the formula. You will get the answer. Okay, what am I saying? What am I saying is, I'll take a question. Here are some simple errors. Let's say they will say, while doing any calculations, you are doing some calculations in the laboratory. You are using different instruments to measure the radius, to measure the volume, to measure the surface area, etc. Now, while measuring the radius, you did an error. Or maybe the instrument did an error. You didn't do, the instrument did an error. The radius that you measured is 3.2 centimeter. but the instrument will do an error of 0.1 centimeter. There is an error in measuring the radius, which is 0.1 centimeter. It can be more plus 0.1 or minus 0.1, but there is an error. The instrument is not able to measure correctly. So you need to find. Now if radius is 3.2, you will get some surface area, let's say 99. Now if error is included, that radius is increased by 0.1 or decreased by 0.1, how will it affect the surface area? How will it change the surface area? That is what calculation of errors is. You have done it in physics practicals, calculating errors. So delta S, change in surface area, is ds by dr into change in radius. If say while measuring area, there was an error in time calculation, your clock speed didn't measure the proper time, small error. So what will be the change in area because of error in time? Change in area is rate of change of area with respect to time into error in time calculation. So whatever calculating, whatever quantity you are calculating, error in y, write its differentiation multiplied by whatever is the error. Error in surface area because of radius. So derivative of surface area into error in radius. Percentage error, relative error, these all means one and the same, approximate change. Relative error is change upon original, and percentage is relative error into 100. Okay, now let's use differentials to find the approximate value of 0.009 the whole raised to 1 by 3. All set? Firstly, identify your x plus h. X plus h is 0.00. Whatever function they have given value, that's x. In it, what will be x and what will be h? X is the known value, x we know, h is the small iteration. So 0.009 cube root. What is the nearest cube root that you know? Like square root of 25.2. Nearest square root we knew was 25. The nearest number that you know. For 0.009, the nearest cube root we know is 0.008. Do you all know the cube root of 0.008? It's 0.2. Cube root of 0.008, 0.2. And if x is 0.008, h will be 0.001, isn't it? Substitute x here and calculate. H will be 0.00. First step done. X plus h, x, h. I gave you 4 steps, isn't it? 1, 2, 3, 4. X plus h, x, h is done. Find f of x and f dash of x. What is f of x here? F of x is cube root of x, x raised to 1 by. So what will be f dash of x? Cube root of x, derivative 1 upon 3, x raised to minus. F of x, f dash of x. That's your second step. First step. Third step was substitute x in f of x and f dash of x. Substitute the value of x. X is 0.008. So f of 0.008 is equal to 0.008 raised to 1 by 3, which is 0.2. And f dash of 0.008 is equal to 1 upon 3 times 0.008 raised to minus 2. I can simplify this like, here. Negative power comes in the denominator as 1 by 3, the whole raised to 2. Negative comes in denominator positive, and 2 by 3 splitted. This is 1 upon 3. Cube root of 0.008, 0.2 square. 0.2 square will be 0.04 into 3. 0.12. Can you see? Third step done. And fourth step is use the formula. That means f of 0.009 is approximately equal to h. What is h? 0.001 into f dash of 0.008 plus. Is the formula correct, boys and girls? F of x plus h is approximately equal to x into f of x plus f dash, x into h into f dash of x plus f of x. F of 0.009 means 0.009, the whole cube root, is approximately equal to 0.001 into, this is 1 upon 0.12 plus f of 0.008. This part needs to be solved very well and then add it to 0.2 to get the answer. Remember, it's an approximate value. Okay, so denominator, in order to make it a proper number for division, multiply by 100 numerator and denominator. That will give me 0.1 upon 12. 0.1 upon 12 plus 0.2. Just doing the continuing the calculations here. Multiplying numerator with 1000 and okay, multiplying. So I'm making the numerator 100 as well as doing. Is it allowed? Is it okay? Multiply by 100, divide by 100. 0.1 multiplied by 1000 is 100 and divide by 1000 is 10 raised to minus. Now divide 100 and 12. 12 8s are 12 8s are 96. 4 carry 12 3s are 36. 4 carry 12 3s are 36 into 10 raised to minus 3 plus 0. This is approximately equal to 0.0083 plus 0.2, which is approximately equal to 0.2083. So the value of cube root of 0.009, the whole raised to 1 by 3. The value of this is approximately equal to, check. You can use your calculators to find 0.2083. All the 4 steps right in front. Great. Can I do one more question? Find the value of f of 5.001 in this. Great, f of x is given. Whatever you are supposed to find, let that be x plus h. Whatever you are supposed to find, it is x plus. Find out x and find out h. The nearest integer is 5 and the iteration is 0.00. Don't you think if you put x5, h will be 0.0? First step done. Second, you write f of x, already given to you, and you also write f dash. 3x square minus 7 to the 14x. Third step, you put the value of x. You put x as 5. F of 5 will be 5 cube 125, 5 square 25 into 7 175 plus 50. This is minus 50 plus 15 minus 45. And f dash of 5 will be 5 square 15 into 5 square 25 into 370 minus 14 5 is 7. Okay, fourth step, use the formula. What is the formula? F of x plus h, f dash of h into f dash of plus x plus h, that is 5.001 is approximately equal to 0.001 into f dash of x is 5 plus f of x 0.005. What will happen? 35 minus 0.005, 34.995. Just check. Yes, my dear boys and girls. Very big thing, minus sign missing. Minus 34. This is how you solve questions on approximation. Well, let's move on to the last major topic, maxima and minima. Are you guys in for it? Non-stop. Yes, going on non-stop. Maxima, minima, observe the 3 graphs. First graph, this point is C, a point in the left side C minus H, on the right side C plus H, 3 points. Let us call these points as neighborhood. So in the neighborhood of C, there is C minus H, C plus H. C minus H, C plus H. Now when you try to look at this area, in this graph, in the neighborhood of C is at the lowest level. C will be called as local minima. In the neighborhood, it is at the lowest level. That means in the local area, it is at the lowest level, local minima. Here if you try to notice the point C, in the local area, if you notice in this area only, don't go anywhere else. In the local area, this is the highest point, it is called as local. So points left to it are at higher level, but this is at the lowest level. Okay. Observe this graph. There are different points, x1, x2, x3, x4. Don't look throughout. Look only in this area. x1 is at the lowest level. It is called local minima. Minima. मा को याद करेंगे. x1 is the local minima and the value of this f of x1 is your local minimum. This is the minimum value. Where is the minimum value? At x1. How much is the minimum value? F of x1. Local minimum happens at x1. How much it is? F of x1. Substitute the point in the function to get the minimum value. This is the minimum point. Look at x2 in its local area. Isn't it the highest point in its local area? It is called as local maxima. Corresponding function, that is your f of x2, will be local maximum. Local maximum is f of x2, local maximum is x2. Similarly, your x3 will become local minima, x4 will become local maxima. If I don't use the word local, you have to understand it's by default now. Again and again, I won't keep using the word local. If I say maxima, minima, understand it's local. So local matlab in their own area. On noticing the maxima and minima, what we notice? For maxima, what happens? Initially the slope is increasing, then constant, then decreasing. Agreed? Increase, constant, decrease. That is slope. Slope is first derivative. Slope is first derivative. So first derivative tells us whether it is maxima or minima, isn't it? The slope tells us whether it's maxima or minima. When you check the slope at C minus H, it's increasing. When you check the slope at C, it's 0. When you check the slope at C plus H, it's decreasing, coming down. Increasing, 0, decreasing. Don't look at this diagram. Don't look at this, just here. On the left, increasing, 0, decreasing. Increasing, 0, decreasing. What is this point? Maxima, isn't it? Left to right, up, constant, down, maxima. So how will you form the minima? Down, constant, up. Less than 0, equal to 0, greater than 0. Less than 0, equal to 0, greater than 0. Minima. Condition for minima. Less than 0, equal to 0, greater than 0. Less than 0 in the left side, equal to 0 at C, greater than 0 at C. Point of inflection, very important. What is this point of inflection? On the left, function is increasing. Slope, tangent I am trying to draw. On the left, tangent is increasing. At C, it is 0. On the right, it is again increasing. So left side, C minus H, increasing, constant, increasing. Increasing, constant, increasing. So is it maxima or a minima? It's neither maxima nor minima. It is called as point of inflection. Very important, it is called as point of inflection. If it's increasing, constant, increasing. That means the nature is not changing. The nature is not changing, then it will be point of inflection. Or it can be other way also. Decreasing, constant, decreasing. Then this point is point of inflection. Spelling can be this or that. I have written two spellings, both are correct. Infection nahi bolna, inflection. So inflection means after that point, at that point, derivative is 0. At that point, slope is 0. At C, the slope is 0. But what happens before C and after C? No change. Before C greater than 0, after C greater than 0. Sir, before C also increasing, after C also increasing. Or if I take the second example, before C also decreasing, after C also decreasing. Before C, C minus H, it's decreasing. After C, C plus H, also it's decreasing. Decrease, 0, decrease. No change. These are called at point of inflection. If there is a change, decrease, constant increase. This C is called as critical point. Critical point. Here also this C is called as critical point. Critical point means when there is a change. Critical point means when there is a change. Before and after that point. Before and after that point. Before it was increasing, after it's decreasing, it's a critical point. Before it was decreasing, after it was increasing, critical point. Like we say, critical stage in our life. A critical stage is when there is a big change in our life happening. Either you are earning too much and you come down, you lose your job. It's a critical stage from up to low. Or either you are earning very less and suddenly overnight you become a famous star, low to high. That's a critical change, isn't it? Critical time of your life. So critical point means there should be curve, there should be some change. Whereas point of inflection doesn't show any change. You were earning, you are constantly decreasing, then constant, then again your earning is going down. Or you were, you were earning more, then constant, then again you are earning more. There is no sudden drop or sudden rise. Point of inflection. So first derivative test. There are two tests to solve questions on maxima and minima. First derivative test, second derivative test. First derivative test is very much like your increasing decreasing function. What we do is plot the critical points on number line, and if the function is rising from positive to negative, that is before it was increasing, then it started decreasing. What will you say this x1 is? Minima, maxima, local maxima, I mean to say. If the slope was decreasing and after this point also it is decreasing, x2 is point of inflection. x3, it was decreasing and after x3 it started increasing. x3 will be your point of maxima. Decreasing, point of minima. What am I doing? Decreasing. So this x3 is minima, and then increasing, again increasing, it is point of inflection. So positive to negative maxima, positive to negative maxima, negative to negative inflection, negative to positive minima, and positive to positive inflection. Just do it with your hands. This is going to help you write maxima minima very well. Once you can decide the sign of f dash of x, this plus minus is nothing but sign of f dash of x, first derivative test. Once you know plus minus sign, you can easily tell whether it's maxima or minima. These are the steps. Look at the first four steps, absolutely same. F of x, f dash of x, put f dash of x equal to 0, you'll get the critical point. Critical point, you will try to find the sign of f dash of x either by table method or by wavy curve. That is on a number line, you will find out plus or minus. And based on that, plus to minus maxima, minus to plus minima, plus to plus or minus to minus, no change, inflection. You will conclude. Now sometimes what happens, you will also get the first derivative 0 when the point is non-differentiable. This is maxima but non-differentiable. This is minima but non-differentiable. Non-differentiable means first derivative does not exist. Just telling you the case. And there is second derivative test. Second derivative test simply says it is also used to find the local maxima, local minima. If second derivative greater than 0, you will say it's local minima. Second derivative less than 0, local maxima, and if second derivative is equal to 0, you will go back to first derivative test. Now, when to use first derivative, when to use second derivative, it's absolutely your choice. No terms and conditions, no hard and fast rule. Whatever is convenient to you, use that. Steps: f of x, f dash of x, critical point. First 3 steps same. Fourth step, find the double derivative. If it's greater than 0, minima, less than 0, maxima. Ready? Ready to solve a question? Maxima, minima. Find all the points of local maxima and minima and the corresponding maximum value and minimum value. It is a 6-mark question, guys. First step, you have to find f of x. I mean, it's written. It is going to be a lot of calculation, so I will use a calculator. Brain. F dash of x will be equal to minus 3 by 4. Derivative of x raised to 4. 4x. 3 are 24x square minus 45 by 2. Derivative of x square is 2x plus c. 4 cancel. Minus 3x cube minus 24x square minus. Can we take something common? Yes. Minus 3 common. Minus 3x common. X can also come common, right? We have x square minus 8x, not minus, plus, and 15. Can we factorize it? 15 now. 5 3s are x plus 5, x plus. Do you all know how to use wavy curve? In this, you have to write down the critical points, putting this equal to 0. Critical points are, see, you have to put each term 0, so don't forget about this x. That is x minus 0. This is 0, or from here x is minus 5 or x is minus 3. 3 critical points we get. Fourth step, find the sign of f dash of x. In different regions, find the sign of f dash. Minus 5, minus 3. We will start with negative. We will start with negative because there is a minus sign here. Because of the minus sign, we will start with negative. 0. 0 is coming from an odd term, minus changes to plus. Minus 3 also from an odd term, plus to minus. Minus 5 also from an odd term. Now, once you know this minus and plus, if the question is increasing, decreasing, you will say here it's increasing, remaining to decrease. If the question is maxima, minima, whatever I'm showing, you will not show in the exam for your understanding. Plus to minus, maxima. Minus to plus, minima. Plus to minus, maxima. So question says, what are the points of local maxima? Local maxima are at x equal to minus 5 and x equal to 0. Local minima is at x equal to minus. Can you see? Fifth step, they also want you to find the corresponding maximum and minimum value, which means substitute x equal to minus 5 and 0 in the function, and also substitute x equal to minus 3 in the function. Here you will get maximum value. Here also you local maximum, of course, local maximum value and local minimum value. Maxima, maxima, minima. So substituting it in the function. Here is the function, boss. Don't get. This is the function. Put x as minus 5. Long calculation here. I'll find f of 0. 105. Can you find the remaining two? किसी को पता नहीं चलना मैंने कहाँ से आंसर निकाला. कोई कुछ नहीं बोलेगा. कोई कुछ नहीं बोलेगा, बस सॉल्व करेगा पॉज करके। अगला क्वेश्चन यार, मैक्सिमा मिनिमा इन अ क्लोज्ड इंटरवल। When you find maxima and minima in a closed interval where the endpoints are given, the boundaries are given, the limits, upper limit, lower limit are given, it is called as absolute या global maxima minima. Whenever the interval is mentioned, it is not local maxima minima. लोकल की बात नहीं कर रहे, अब हम लोकल से निकल चुके हैं, अंडरवर्ल्ड की बात करेंगे, यानी एब्सोल्यूट मैक्सिमा मिनिमा की बात करेंगे, ग्लोबल मैक्सिमा मिनिमा की बात करेंगे। फॉर ग्लोबल मैक्सिमा मिनिमा, in this question the highest point of all is x1, that's your absolute maxima. Lowest point, this is the lowest or this is the, I think this is the, ये ऊपर है नीचे, this is the lowest, so x2 is your absolute minima. Corresponding f of x1 will be maximum value, f of x2 will be minimum value. Question of this is absolutely simple, matlab just follow this 5 steps, done. F of x, f dash of x, f dash of x0, get the critical points. Fourth step is important. Now you will find f of x at all the critical points and endpoints. CP is critical point. Now you will try to find the value of function at all the critical points that you are getting. For example, the critical points are x1 and x2. Critical point means where the derivative is 0. x1 and x2 are critical points. A and B are endpoints. So you will find the value of function at x1, x2, A, B. Whichever is highest will be absolute maximum, whichever is lowest will be absolute minimum. So do not ignore the endpoints now. Global will always occur when there is limit given. Can you see limit given? Find the maximum minimum of this function, limit given. That means you are finding now absolute maximum minimum. Limit interval is 0 to pi by 2. Follow the 5 steps. First step, function is given. Second step, f dash of x. Cos 6 plus 1 by 2, derivative of cos 2x is minus sin 2x, derivative of 2x is 2 cancel, that makes it cos 6 minus sin 2x. Okay, next, and this is cos 6 minus 2 sin x cos 6. Try to factorize as much as possible. Try to find f dash of x in the factorized format. 1 minus 2 sin x. Right, second step done. What is the third step? Put f dash of x equal to 0 in order to get the critical point. You can do that. Third step, putting f dash of x equal to 0. So first thing, cos x equal to 0. Second thing, 1 minus 2 sin x equal to 0. From first part, what will be x? Cos x is equal to 0 in first quadrant. Where is cos 0? At 90 degree. And from the second part, sin x is equal to 1 by 2. X will be in first quadrant, where is sin x equal to half? At 30 degree. These two are the critical points. Shall I use second derivative test? Because your parvad raha hai na yaar. Find the double derivative. This is your single derivative, right? Differentiate it again. Derivative of cos x is minus sin x. Minus derivative of sin 2x will be cos 2x. By chain rule, derivative of 2x will be 2. Got the double derivative. Taking it so that you get the idea of both. Now this double derivative have to be calculated at the critical points and end points. This has to be calculated at the critical points. Well, do we need to find maxima minima? No. You are done. This step is not needed. What we need is sorry guys, little, yeah, finding the value of this at pi by 2, but yeah, put 90. How much is sin 90? 1 minus 2 times pi by 2, and cos 180 is minus 1. That makes it plus. Minus 1 plus 2 will be double derivative greater than 0. That means x equal to pi by 2 is what? Maxima or minima? We need to know now what is maximum. So x equal to pi by 2 is minima because double derivative greater than 0. Now put x equal to pi by 6. Well, this fourth step, double derivative or single derivative, is in local maxima minima. We are going for absolute maxima minima, and that's why I said this step is not needed ideally. Pi by 6, sine minus 1 by 2 minus 2 times cos 2 pi by 6. 2 times cos 30 is again half. Minus half minus 1. Minus 3 by 2 less than 0, that is x equal to pi by 6 is minima. Less than 0 means maxima. Local maxima, local minima we have. But the question is not for local maxima minima. I did it only to show you double derivative. There was no other purpose behind it, just to show how double derivative works. What we do in this thing is, after you find directly, after the critical point, you directly find the value of function at critical point and end point. No need of doing this step. Okay, this was just an additional step. The fourth step is find f of x at critical points and end points. 0. One of the critical point is same as end point. What is f of pi by 2? F of pi by 6 and f of 0. Here is the function. Substitute x as pi by 2 sine 91 plus half into sine of 2 times 90. 180 sine 180 is minus 1. 1 minus half. Pi by 6. Sine pi by 6 is half plus 1 by 2 times cos 60 will be again half. Half plus 1/4 will be 3/4. And f of 0 is sine 0, 0 plus 1 by 2 times cos 0, 1. This is 1 by 2. What is the absolute maxima and absolute minima? Can you say this is the absolute maxima? And these two are the absolute minima. This is your fifth step. Highest 3/4 and lowest half. I will just check. 1 minus half is half and 0 plus half is also half. Hopefully I have not done anything wrong. 1 plus cos 90 cos 180. Okay, and 0 plus cos 0, 1. ठीक है यार, सही है. At 2 points you have absolute minima and at 1 point you have absolute maxima. So fourth and fifth step here, this was just to show you how the double derivative test works. If it was local maxima, if it was local. For a moment I forgot that local. This is last part of the chapter is word problems. Now when you open the exercise, you will see a lot of questions, a lot of word problems. Each of them will be solved by just 5-6 steps only. In any given question, read the question nicely, carefully. There will be a word given. There will be some extra information, like given the perimeter is this much, given the area is this much. So whatever is that given, you have to write down. And that given quantity will always be constant. If it's perimeter, perimeter is constant. Area is constant. Write down the given. Next, find the function f. Now, how to find the function? Read the question carefully, and wherever you see the word maxima or minima, that's the function. Maxima is the volume. Least area. Least means minimum. So, wherever you find the maxima, minima word, that's your function. Catch it. The function is ready. Function is area, function is volume, function is something else. Function you will get near the word maxima, minima. But then, if let's say the function is volume of a cone. What is formula for volume of a cone? 1/3 pi r square h. It has two variables r and h. It has two variables r and h. We don't want two variables. We don't like two variables. We need all the functions in single variable. That's convert h in r or r in h. Remember rate of change, the very first question of today's class. Converting the variables is absolutely important. Once you're done, you have won the question. You have got the points. The teacher is impressed. The teacher is going to give you marks now. Don't worry. So converting single variable, and how do you convert? Always with the help of given. Substitute the given in the function. using given. Substitute the given in the function, you will get single variable, either r or h. And now whatever is the variable, differentiate with respect to variable. If the variable is r, differentiate with respect to r. Differentiate with respect to single variable. These are the hints. This will really help you solve the questions. And if you've already done it, you know what I'm talking. How will you get single variable? Substitute given in step 2. So next step is differentiate it, put it equal to 0, get the critical points. Once you get the critical points, find the double derivative to confirm whether it's maxima or minima. Once you get the double derivative to confirm, question says maxima, you will get maxima at that point. If question says minima, find the point at which there is minima through the double derivative test. We will 90% use double derivative in word problem. And in the end, conclude your answer as per the need of question. If the question says find the x and y, find the variables, or find r and h, radius and height, you will find that. If the question asks you to prove something, then you will prove that. So let's do this 6 steps in the word problem which I have for you. Show that height of a cylinder h of maximum volume that can be inscribed in a sphere of radius a. Okay, the sphere radius is a. The radius of sphere is a. Is 2a by root 3. Show that height of a cylinder, let's say height of a cylinder is h. Height of a cylinder of maximum volume that can be inscribed in a sphere of radius a is 2a by root 3. This is what you have to show that. What is A? A is radius of sphere. Can you see its radius of the sphere? Capital R is radius of base of cylinder. H is height of cylinder. So halfway it will be h by 2. And now in this triangle OAB, you know all the terms: capital R base of cylinder, small h by 2, half height, and A is the radius of sphere. In this, firstly, okay, let's go step by step. The 6 steps will follow. What is given? What is given? Is anything given in the question? Yes, it's given. A lot of information is given. That is in triangle OAB. If you apply Pythagoras theorem, Guru theorem, a square will be equal to h by 2 the whole square plus r square. Simplify. Whatever is given. A is given, radius a, that will be constant. The radius of sphere is constant. Next thing, what is the function? We have written the given, now we want function. What is the function? Function is near the word maxima minima, cylinder of maximum volume. Hola, we got the function. Function is what? Volume, volume of cylinder. Volume of cylinder. The function is volume of cylinder. Formula for volume of a cylinder, pi r square into h. Pi r square. Third step. Convert this 2 variable in 1 variable. Oh, how to convert this 2 variable in 1 variable? There you go. Can you see? R square is equal to a square minus h square by 4. This r square, how to convert 2 variable in 1 variable? Use the given in the step 2. Use given in step 2. I have used given in this step 2. Given in step 2. R square can be written as a square minus h square by 4 into h. Simplify. Go on simplifying till you get a proper nice equation. A square h minus h cube by 4. Guys, h is the only variable. A is constant. Why? Because radius a is given, it's constant. A is constant. Voila! You got function in single variable. Volume having only 1 variable. You have won the question now. Go for differentiation. You will differentiate it with respect to variable, not t, huh? dv by dh. Pi is a constant, a square is a constant, derivative of h will be 1, h cube derivative will be 3h square upon. Third step is differentiate, put it equal to 0, etc., etc., isn't it? dv by dh equal to 0, which implies pi times a square minus 3h square by 4 equal to 0. Simplify. This will give me a square is equal to 3h square by 4. From here, h square is equal to 4a square by 3. Or h is equal to squaring 2a upon root 3. Man, we already got what you are supposed to prove just by putting the thing equal to 0. Critical point, h is 2a by root 3. Proof. But is the question over? No, wait. Third step is over. What is fourth step? You need to confirm with double derivative that we are talking about maximum value. No one you have mentioned that it's maximum volume. So double derivative has to be taken. Where should I take? This is your single derivative. Differentiate it again. Pi is a constant. A square is a constant whose derivative will be 0. 3 by 4 is a constant. Derivative of h square is 2h. So double derivative at the point that we are talking, h equal to 2a by root 3 will be minus 3 pi, 2 ones are 2 twos are, minus 3 pi by 2 into h, which is minus 3 pi by 2, h is 2a by root 3. Can you see this whole quantity is less than 0? And less than 0 means maximum volume. We are differentiating volume, so volume will be maximum, less than 0. That is what is needed. Very well. And fifth step, I said conclude as per the question. So as per the question, you want to show that this is equal. Therefore, proved h is equal to 2a by root 3. All the 6 steps. Yeah. Where is that one step, man? Double derivative is 5th step. This is 4th step. Single variable was 3rd step. 3rd, 4th. I wrote 4th again. Mama will be so proud of 6th. All the 6 in front of you. Guys, use this technique to solve remaining questions and enjoy solving this chapter. Hope I helped you a bit in revising the entire chapter. Thank you so much, and let me know in the comments if you need anything extra. Any feedbacks, comments, suggestions are welcome from all of you. Thank you so much. Keep smiling. Take care. Bye-bye.